Hey guys, welcome back. We got day 21. We're talking about bonding today, chemical bonding. And so these are the learning objectives. And we're going to be talking about bonding. We're going to do these through the next few videos. All right, so first up, chemical bond, right, is the sharing. We're going to share or transfer electrons. And what type of electrons? Many times, right here in Chem 1, these are going to be valence electrons, right? And the goal, right, is stable electron configurations, right? That's the goal, right? And the three types that we're going to talk about, three types of bonding, right? Ionic, right? That's ionic, right? Ions and ionic bonds, right? These ones are, metal, non-metal, opposite sides of the table, the periodic table. Then we have the sharing, right? The sharing, right? Okay, and these are above the stairs in H. All right. So ionic is transfer, covalent sharing. Metals make metallic bond with electrons pooled, but we're not going to really dive into metallic bonding in this course. All right. So again, we got the ionic bond where the electrons are transferred, and we have the covalent bond where the electrons are shared. And we're going to show you a little bit about the ionic bond, but we're going to mainly focus on covalent bonding. All right. So when we talk about ionic bonding, all an ionic bond would be if you have, we'll do the iconic Na, and that has a valence electron. We'll give it an orange one. And we have Cl, and that will have pink ones. All right, so that's an ionic, right? That's the sodium ion with its Lewis dot structure, and it's chloride or chlorine with its Lewis dot structure, and you make, going on, Na plus, and then in brackets Cl minus, and the electrons go in there, and that's a Lewis structure for sodium chloride. That's it. That's all it is. So we're not going to really dive into much with that because it's pretty straightforward, pretty simple, and there's not much behavior prediction that we're going to do with it. We are going to dive into the non-metals, right? The covalent compounds. And the first rule we get to talk about is the octet rule. Oh, that's not a... I'm going to go highlight there. I wanted to highlight that. Octet rule. And that's, we want 8 electrons, right? And that is because we have atoms that want to be isoelectronic with the noble gases, right? We want to have the electron configuration of neon, the electron configuration of argon, the electron configuration of krypton or xenon, right? And so they're going to try to share electrons to get to 8 in their valence shell. Now, a few of them, right, especially H and B, right? We're not going to do much with the other two. They can have less than 8. Less than 8, all right? Hydrogen would not want 8 electrons. Hydrogen has 1 proton. If it's sharing 8 electrons, it would be -7, effectively. That's not okay. And so hydrogen just makes 1 bond, all right? And so when we go with this, covalent bonding, all right? Covalent bonding is the sharing of electrons. We're going to share. And Lewis, right, came up with this, 1916, that we're going to represent molecular compounds, the ones above the stairs, which depicts or shows neighboring atoms as sharing some or all of their valence electrons to attain the octet, which would be, of course, 8 electrons, or the duet, which would be 2 electrons for hydrogen. All right? Now, sharing electrons is, you know, how these are bonded, but what is actually a bond is two electrons. So in a pair of electrons in pairs, right? So that's two electrons equals one bond, right? And then we're going to share the right number of pairs so that we are equal to the next noble gas. So if you have carbon and nitrogen, they're going to try to look like neon. Phosphorus, sulfur, chlorine try to look like argon. If you have oxygen and chlorine in a compound, oxygen is going to try to look like neon, chlorine is going to look like argon. Okay? So what are the guidelines to drawing these things? All right? Because there are guidelines for this. Now, my first guideline, all right, so guidelines for drawing Lewis structures. Oh, for drawing and I'm saying guidelines because it's not a hard fast rule, okay? It's not a hard fast rule. This is the options you have, and we're going to try to find the best decision with kind of these guidelines. We're going to try to guide us to make what the compound should be. All right? And so the first one I have is use pencil. Use pencil. Or like what I'm using, a device that you can write on and erase. All right? Use pencil because erasing may happen. And it's not really may happen. Erasing will happen. All right? Okay? Just why? Because it's trial and error. It's by inspection, as we call it, right? Unless you know what it is. All right? Okay? Now, there's really a half in here, right? Write the correct skeletal structure for the molecule, right? That implies you have the correct formula of the molecule as well. All right, so if I have the wrong formula, I'm not going to have it. So the right skeletal structure, right? And so what does the skeletal structure mean? That means how the atoms are arranged. Now you look down on the screen, there's these small molecules. Small molecules, there's like H2. There's only one way to arrange H2. Two H's, that's it. However, when they get bigger, right, there's more and more ways to arrange the atoms. And so we got to make sure they're in the right arrangement. Now, we're not going to get crazy big, okay? But we will get bigger, and there's options sometimes, all right? It kind of like some of you move a lot. If you live in a small little space, sometimes there's not many ways to arrange furniture at all. Like a bedroom that's small, you can put the bed in one spot, right? But if you have a huge bedroom, there's many ways sometimes you can arrange the bed. And so that matters, all right? How are you going to arrange the room? All right? How are you going to arrange the atoms? So you need to put them in the right order, or right arrangement, right? Just like if you take anatomy and physiology, right? The humerus and the femur and the radius and the ulna, they have spaces to go, right? You can't just put them anywhere. Then you calculate the total number of valence electrons. This should be valence electrons. Valence electrons, all right? Valence electrons for right? Every atom. So we just put all of them together. Then we distribute the electrons among the atoms. You give octets, or duets for hydrogen, as many atoms as possible. All right? So you bond them, right? So you one bond, and two, you fill octets. And then three, if any atom lacks an octet, you form double or triple bonds as necessary. Now, there's also 5 extra electrons go on the central atom as lone pairs. All right, so we have a definition now. Central. There's 2 types of atoms. There's central atoms and terminal atoms. A central atom, like X here, can have more than one bond. A terminal atom, right, only has one bond. All right, so A, Z, and Y would be terminal atoms in this case, and X is a central atom because it's bonded to more than one, right? So you either are central because you have more than one different atom you're bonded to, or you're terminal because you only have one atom, all right? So let's do this. Let's dive in to some of these and figure out what's going on. H2, first thing, how many electrons? Well, there's two H's, and they each have one electron each, so I have a total of 2 electrons. So then we got to write it out, H and H. Well, there's only one way to arrange that, isn't there? Not could you write it H to H like vertically, or H to H at a 45-degree angle? Sure. But we're not going to worry about that. But you could do that. All right, you could definitely do that. Now, if we do the valence dots, I got 1 for H and 1 for H, right? What happens is this becomes a 2-electron bond. All right? And so what we do is we go H to H, and then we just draw the bond. Boom. Right? And so this is a 2-electron bond. So that line represents the 2-electron bond. Okay? Now, if you remember, these electrons, it's a dynamic situation. All right? They're not just hanging out between the two hydrogens static, but we draw it as a line to represent when you got H2 singly bonded, or HH singly bonded. HF. Let's do the electrons. H has 1 valence electrons, and fluorine has 7 electrons. Now, how do I know that? How do I know that, right? Remember, the electrons, the valence electrons are the outermost S and P. And if you're looking at your periodic table right now, right, group 1 all ends in S1. So does hydrogen. So it has 1 valence electron. Group 17, right, has 7 valence electrons because they end in S2, P5. So 2 and 5 is 7, right? So group 1 always has plus 1. Group 1 always has 1 valence electron. Group 2 is 2 valence electrons. Group 13, 3 valence electrons. Group 14, 4 valence electrons. 15, 5. 16, 6, 17, 7, 18, 8, except for helium. Helium only has 2 electrons, valence, because this one has 2, right? So your valence electrons comes from the periodic table, basically what group they're in, but it's the outermost S and P. All right, so now that's how I know H has 1 and F has 7. Skeletal structure, H and F. Could you do FH? Sure, not in IUPAC order, but sure, you can be that way. First thing you do is bond them. 2. And then we're going to fill in the octets. Well, H is full now. So I have 4, 6, 8. And if we look, H has its duet there. And F has 8. Right? And so what do we have? We have 2 electrons, bonding pair. And we have, these are lone pairs, not bonding. So that's what we have here. So fluorine has 8 pairs, 8 electrons, 4 pairs, 3 non-bonding pairs, and 1 bonding pair. All right. Let's try F2. We have 2 times 7 electrons for a total of 14 electrons. I got 2 Fs, F and F. First thing we do, bond them. 2. Then you fill in the octets, doesn't matter which one. 4, 6, 8, 10, 12, 14. So if I look, the fluorine on the left has 2, 4, 6, 8, right? That's 2, that's 4, that's 6, that's 8. Perfect. The fluorine on the right has 2, 4, 6, 8. And so now they both have 8. We're happy. Oxygen. Oxygen has, right, 6 electrons, valence, right? So that's a total of 12 electrons. I have 2 oxygens. First thing we do is bond them, 2. Then we have 4, 6, 8, 10, 12. Ooh, what do we do here? It just doesn't look right. Well, some students have had automatically like to do this. Put the electron there. And now it looks even. All right? But that's bad. That's really bad. Okay? We don't want to do that. Why don't we want to do that? Well, 2, 4, 6, 7. 2, 4, 6, 7. That's not good. What we really need to do is move, right, the electrons here, and that becomes another bond. Right? That becomes another bond. Right? Because if we look up here, if any atom lacks an octet, we form double or triple bonds as necessary to give them octets. So now oxygen has 2, 4, 6, 8. And this other oxygen on the right has 2, 4, 6, 8. So now they both have 8 electrons. So we form a double bond. All right. And then nitrogen. Let's look at nitrogen. What happens? I have 2 times 5 electrons. So for nitrogen, I got N, N. First thing we do is bond them. 2, 4, 6, 8, 10. Well, that obviously doesn't look right. We could, all right, again, try that. But that doesn't look right. That's not our rules, is it? All right, we're going to undo that. All right, we are going to look, and it says, again, it says, if any atom lacks an octet, you form double and triple bonds. So we erase those. Make it a triple bond. Let's look. 2, 4, 6, 8 for the left nitrogen. 2, 4, 6, 8 for the right nitrogen. That works. All right, that works. Methane. We have 4 electrons plus 4 times 1 electron for hydrogen. All right, so carbon has 4 electrons. Valence. Carbon has 6 electrons overall, but 4 valence. Hydrogen has 1 electron. That's valence, so that would be 8 electrons. Now we have to determine something. A central atom. Remember we talked about central atoms up here, right? We got central atom. How do we tell the central atom from the terminal atoms? Well, if hydrogen only makes 1 bond at this point, is it going to be in the middle? All right? So the central atom, I'll write it in blue here. Central atom is typically, right, first, and we call the least electronegative. But most importantly, it's not F or H. Okay, we'll learn electronegativity. You can look up the words, how atoms pull electrons to themselves. But right now, written first, least electronegative, and it's not F and it's not H. If there's an atom that wants to be in the middle, right? If you're looking for, hey atoms, I'm looking for a volunteer to be in the middle. Carbon is your one that wants to be in the middle. Carbon likes to be in the middle. So we'll put carbon in the middle. And at this point, all right, all we have to do is put 4 H's. H, 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 right? North, south, east, west is good, right? You can do northeast, southeast, northwest, southwest. It does not matter. Right now we're just doing that. And then we got to bond them. 2, 4, 6, 8. Is that good? That's all the electrons I have. Well, is that a duet? Yes. Is that a duet? Yes. Is that a duet? Yes, because hydrogen likes duets. That's a duet. And then does carbon share 8 electrons? Sure does. So that's all methane is. 4 CH single bonds. All right. Again, we'll do a couple more here. Ammonia. NH3. Electron count. 5 for nitrogen, plus 3 times 1 for hydrogen. And again, you have to, at this point, have your periodic table out, because I don't expect you to memorize these things. I think that would be unreasonable. All right, use your periodic table. And again, hydrogen's group 1 has 1 valence electron. Nitrogen's group 15 has 5. Central atom. Well, nitrogen's written first, and it's not hydrogen. We know that. Okay, so I have N, H, H, H. Bond them. 2, 4, 6. Now I have 2 more. I can't put them on H, can I? Because H is full. So the extra electrons go on the central atom as a lone pair. Right? It's not bonding. And so now each H does have its duet, right? Duet, 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 and then nitrogen overall has 8 electrons, doesn't it? 2, 4, 6, 8. So that works for ammonia. Water. Valence electrons. We have 2 times 1 electron for hydrogen, and oxygen's in group 16, so there's 6 electrons there. Total 8 electrons again. Who's in the middle? Well, H is written first, but we know H is not in the middle. All right, so I'll merge to H, O, H. All right, bond 2, bond 4. Then we got 6, 8. All right. And so now if we look at this, does each hydrogen have 2 electrons? Yes. Does oxygen have 8? Yes. There we go. Now some of you might be aware, all right, and we're going to get to the actual shape of water, because a lot of times you might have seen water and you don't see it in a straight line. That's okay, all right? Right now we're not actually worried about you drawing the 3-dimensional shape correctly the first try, okay? I just want you to start to learn how to put these together. All right. CO2, electrons. Carbon's group 14, so there's 4 electrons, plus 2 times oxygen 6 electrons. So that would be 16 electrons. Who's in the middle? Well, carbon's written first. Carbon should be in the middle. So I have O, C, O. First thing we do, bond them. 2, 4, 6, 8, 10, 12, 14, 16. There we go. Is that good? Well, oxygen has 2, 4, 6, 8. Fantastic. Oxygen has 2, 4, 6, 8. Fantastic. Carbon, 2, 4. 4 does not equal 8. So we don't have enough on the central atom. So what I would do is take a pair there and a pair there, a pair from each oxygen, and there's a reason for that we talk about later, and right? But we take a pair from each oxygen, and we'll make, oh, I wanted eraser, sorry guys, erase, and, oh, try that again. Erase and erase. And then we'll put the double bonds on both sides. Oh, that's a highlighter. Double bonds on both sides. And now let's try it again. Oxygen still has 2, 4, 6, 8. Oxygen still has 2, 4, 6, 8. And now carbon has 2, 4, 6, 8. So now that works. So that is the introduction to Lewis structures for us. All right. And I think we'll stop there. We'll continue this in the next one. Take care, guys.